Imagine trying to power up your home or your phone. You probably never think about how the electricity gets to you. But did you know there are two types of electrical current used all around the world? Alternating current, AC, and direct current, DC, are the driving forces behind most of the electronics we use every day. But which one is better? Let's find out. Direct current, or DC, is the type of current where the electric charge flows in one direction only. Think of it like water flowing through a pipe in a single direction. No turns, no changes. Batteries, like the ones in your phone or remote, are powered by DC power. Generally, DC generators are used to produce DC power, and for that, an engine is used to rotate the DC generator. It's steady and consistent, providing a constant flow of electricity from one point to another. Now, let's look at alternating current AC. In AC, the direction of the electric charge alternates, or switches back and forth. This means the flow of electricity moves first in one direction, then reverses, and continues doing this rapidly. In a large-scale power plant, alternator is used to produce AC power. Generally, 50 or 60 Hz of frequency AC power is used, where the voltage range is between 120 and 220 volts for home and 440 volts to 33 kilovolt for industry. But the frequency of 50 to 60 Hz remains the same. AC is easier to transport over long distances. That's why the AC power grid is the main power distribution system around the world. You can check the I button for how power grids work, from generation to your home. Now, what's the difference between DC and AC? DC flows in one direction, making it ideal for small electronics and devices like flashlights, smartphones, and laptops. AC, on the other hand, constantly changes direction, making it better suited for powering large systems like the electric grid and home appliances. The main difference lies in how they flow and the efficiency of transportation over long distances. DC has some advantages, especially when it comes to smaller, portable devices or as a backup emergency power. Pros: steady and constant power. Ideal for low-voltage applications like electronics and charging devices. Efficient for storage, think batteries. Cons: harder to transmit over long distances. Long-distance transportation cost is very high compared to AC power. Voltage needs to be converted to higher levels for efficient transportation. AC has some clear advantages when it comes to powering every home and industrial system in modern days. Pros: easy to convert to different voltages, thanks to transformers. More efficient for long-distance transmission with less cost compared to DC power. Powers large systems like household appliances and heavy machinery. Cons: less efficient for small electronics. The alternating nature can cause power loss in some applications. AC can't be stored like DC. So, which is better? It depends on the application. AC is better for long-distance power distribution, which is why it powers homes and cities. DC is better for small electronics and batteries, where a steady, unidirectional flow is required. In fact, modern technology uses both, AC for power grids and DC for devices like electric vehicles and solar panels. The future may even bring new ways to combine both currents for more efficient power usage. Subscribe for more curious science with Electroscope.